Hi guys, well, small and subtle don't really do this thing any justice. This is a private branch exchange, or PBX as you know it, a business phone system from a customer that we upgraded to a SIP based system. I've already done the phone for this. The phone may be posted before or after this, so go and have a look for that if you're interested. But this is towards the end of the life of these type of systems, where you have your custom digital exchanges or desk terminal type things, and these would probably a couple of years later start supporting SIP. I've got a Panasonic version of this that does indeed support SIP trunks, and I believe this may even have a network interface on it as well. So it's big and bulky, so let's just get into it as best I can. I can't zoom you out any further either, but to be fair, quite a lot of what's in here is power supply, so we don't need to really worry about that. That's on the floor now. As you can see, some of the cards are out. So let's just cover the easy bit, power supply. Zoom you in. Right, most of these are modular, so you will generally have a CPU card which has a number of lines and a number of functions on it just to get you going, and then you'll have line cards, and this one is no exception. So I will pull out the CPU card there, and then we have a single line card in this one down here. Now I'll put those one side for a second without throwing them everywhere like the lid did. This is quite literally all that's left now is a very large power supply and a back plane. That's all that's left. We have a power switch on the end. We have a big hulking direct power supply. There is no surface mount in that at all. And we have some... it's not easy to move around in this situation. We have some information there. Whoop, there we go. This is an Aztec power supply, so it's going to be a really good quality, and it's 126 watts with a battery charger output. There was never any batteries with this. So we have 5 volts at 8 amps, minus 48 volts, which is fairly common telecoms voltage at 1.1 amp, and then we have a 7569 volt AC output. 8 VA max, that will be the ring system, and then we have 54 volts at 0.5 amps, which is the battery charger output. I believe that's right. We've got 2 tickets on here for the same power supply. We've got a 128. There's 2 models and it doesn't actually tell us which is which, so yeah. In terms of usefulness, not really. I can get more power out of smaller chargers. I can get more power out of smaller devices. So let's put our line card to one side. Now some of this I'm going on because I know the exchange, we removed it, and we've got an idea what's going on with it. But this is essentially the basic telephone exchange itself. So we will have a limited number of ISDN lines in. It looks like we have 8 digital lines out. And that's really all there is to say about this. So we've got some stuff going on under there. We have a daughter board there. This daughter board looks suspiciously like it is designed to be multi-purpose. And what do we have there? Quite hard to read that. Let's turn the other light on and see if that helps. We have a PCD 80728H, so I'm not sure what that is. It's got an ARM logo on it. That's probably going to wash out now. That's just not going to focus for you. And we've got what looks like suspiciously like a PCI header on there. I wouldn't assume that it is, but that's going to be a additional function of some kind. We've got some flash memory on there, so that will enable some kind of function, so voicemail boxes, hold music, something like that. We have our digital lines coming in here. These are from the phones, and we've got protection and signal conditioning. We've got some isolation going on in these transformers as well. This on semi device which is a 13665, is behind the isolation side of things. I'm not quite sure what that is doing, but looking at where it is in the size of the tracks, that may be involved in the ring side of things. And then we have our final isolation transformer, and then all of our lines are going into this Infineon part here, which is a PER2096, which is going to be some kind of interface chip. And then we're into fairly standard sort of microcontroller type stuff. We do have two ISDN inputs here, and you can see we've got the two isolation transformers here for them, isolation and matching, and then we've got our two ISDN transceivers. We have Ethernet here, we have the Ethernet coil, and we have an AMD PC net there. So this one does have Ethernet functionality. I don't quite know what it will do on this one. And then we have another mystery board over here. Let's just grab the right size screwdriver for that. I'm sure there are people watching this that are a lot more knowledgeable about this system than I am. So again, this is a more modern system. We'll try and find a date code in a second, but as you can see we have an SD card here, and that SD card contains the operating system for the PBX, any options, and the configuration. I don't believe it's being used for hold music, especially as this has a hold music input somewhere and had a cheap BT hold music server there. Right, so all that's doing is protecting these heat sinks. So I'm guessing what we're doing there is power supply related. I can't see any way to safely remove those. Oh, they do just clip off. Oh, they're an unusual package. Well, we've got one off anyway. So yeah, we've got some surface mount packages there with... Can I zoom you in a bit more? Just a bit. Exposed heatsink tabs there. But looking at where they're placed and the fact that they're in here with all of this suggests that they are power supply related. We've got some resistor hybrids there and more isolation. I don't know what that would be. That could be a emergency bypass type system, so that would allow a normal analog phone to work with it. We have a Motorola cold-fired processor. We have a Siemens printer, whatever the hell that is. That's going to be an ASIC. We have some memory. We have some more Infineon parts down there, which I suspect are going to play into whatever's going on here. And it looks like we have a CPLD in the middle and more ROM. So there's not a great deal. So you've got bus interface circuitry going on here. So there's not a great deal going on in this. So if you think about a SIP telephone, let's get you in frame. If you think about a SIP telephone, then you'll come in on a network interface. You then need to drive that network interface. Then that data stream coming in from the network interface needs to be managed by the processor. The processor then has to arrange unpacking of whatever codec is being used for the voice signal and or dealing with any data signals, as well as managing all the overhead for the SIP protocol. Then that potentially has to be either re-encoded to another codec depending on your trunk or where you're talking to, or the data stream is part of the encoded data stream is passed straight back to the next phone. But the processor is doing an awful lot of work in here. Most of what's happening on here is going to be happening inside chips like these, which form the switch fabric, and there is almost certainly a common bus on the back of there. And if we look at this board, do we get any clues as to what that switch fabric may be? Just thinking it may have been reused, but it looks like these Infineon chips may actually be the switch fabric. So if we look at this board, this is a dual ISDN board, and curiously we have provision for mounting RJ45s on here. I don't quite know why you'd do that, but they have done. That's because that's the input, so this is where your lines would connect to, so you can have a bank of RJ45s. It looks like we've got support for we've got our 4 ISDN lines, and potentially we may have room for another 4, although it looks like there's only 2 relays there, so the relays may form part of a failover type circuit. Then we have all of our line interface. We then have a codec, and I can almost certainly say that is a codec. That is a CM something. We'll get that and I'll add it on down the bottom. And then we have another Infineon chip. We have a DSP, which is going to be handling all the codecs. And then we have some RAM, some ROM, some bus interface logic, and a CPLD. I'm curious to see if these are the same date. So let's have a look at our dates. We have a MAC address there, which also further confirms that we're doing Ethernet. There's nothing on that that's of any use. I have to say the printing on these chips is quite hard to see. That might be 01. We've got a date for the battery here of 2001-11. 2011 sounds late for this. That could be 2010 though. That could be 2010. That could be 2010. So 2011 actually sounds right, which for one of these is quite late. We had started the move to SIP-based IP telephone exchanges probably around 2010, so this was very, very late in the game. What have we got here date code wise? Anything useful? No, not there. Right, that says 03, don't believe that. That says 03, okay. Maybe we are 03. That doesn't have a date. Code that I can read. That says 03. What we've got on the relays? 03. Yeah, so it looks like this board is quite a lot older. And this board is quite a lot newer, and I doubt this will tell us anything interesting. So I did look at it, but I thought it said 10. It does indeed date from around 2010. So, as I say, this is quite late in the game for one of these type of telephone exchanges. So what we're possibly looking at here is this comes from an older exchange and the base unit was replaced, meaning this was replaced en masse. I'll have a quick look at the power supply to see if the power supply date matches this board or this, but they went on for a long time. I just looked at something down there. No, I got a serial port on there as well. The thing with these is they just work, or for the best part just worked, but a lot of the telecoms industry would work around the basis that you say, right, okay, I want a new extension configured. Say you're only using 7 of these extensions, you'll get an engineer visit, you'll get billed about £300 for enabling one of these and programming it. Again, something like this where you just need to change a card, you would be paying hundreds of pounds of labour for very little. And it's something that the industry has been very, very protective about. They have not embraced IP telephony particularly well until very recently, and these boxes are now starting to disappear. But a lot of companies still use them. They are reliable. You'll still see the old Nortel, Siemens and BT phones kicking around in offices, and there's no reason to be using them. Again, for things like voicemail, you would pay hundreds and hundreds of pounds to have voicemail turned on and configured. It would often require another board or another option board and hours of configuration, whereas with something modern like Free PBX, you check a box and set your greeting up. So yeah, there's a bit of animosity with the old school telecom engineers and the new school ones, but that really is all that there is in there. And the only thing left to do is we'll just quickly look at that power supply and break everything again. I didn't move you. And do we have anything looking like a date on there? I don't think we do. There's nothing with a visible date there. That isn't actually a power switch, I've just noticed. It's labelled on the top 25, 20 and 50 Hertz, so that will be the dial tone generator. And there's another one behind it which looks like it sets the ringtone as well. Anyway, there you go, that's that. That is a big lump of junk I can now put in my wee bin and get out of my way, and another video for you guys. So yes, don't forget to hit the bell, like and subscribe. Let's get those numbers up. Thank you, take care.